Ah, elements of chemistry. And gold. How would you describe gold? How would you describe anything? Well, you look at it, you see its color, you feel its weight, you feel its texture. And when you're doing that, what you're doing is you're looking at the material's physical properties. And the physical properties are merely those properties that describe the physical attributes of the material. Here's some silver. Contrast this to the gold. Different color, right? It's different weight, too. Different physical properties there. Here's some copper. What color is copper? It's copper. All right? Oh, here's some sulfur. We recognize it's sulfur primarily because of its color. What about the smell? Smell is an example of a physical property. Do you dare me? Not too bad. You might be thinking about another form of sulfur. Now, this sulfur here has a physical property of being just slightly odoriferous. Not too bad. Yeah. But here's a crystalline form. Here's a powder form. These are all physical properties of these materials. And we use them to describe the materials. Physical property describe the look or feel of a substance. They describe its physical attributes. And here's some water. We can look at the physical properties of liquid water. It's a liquid. It flows. It has a certain density and so forth. Let's look at this water from the level of its molecules. Here we've got some water in the liquid phase and also in the solid phase. And if we look real carefully down there into the liquid phase, we see the molecules. Molecules of water, H2O. And these molecules in the liquid phase are tumbling over one another, and that's what gives rise to the fluid character of the liquid water. Over here, with the ice and snow, we have the water molecules, but they're in a locked position. Note, before you have water, and after you have water, in both phases, in the liquid and the solid phase, you have water. And they have different physical attributes. And you can see why. Because in the ice, the water molecules are locked together. As you go from one form to the other, you're in fact changing the physical attributes of a single material. And you do that by changing the conditions, say for example, the temperature. And that's called a physical change. In a physical change, you change the physical attributes of the material, but you don't change what the material is. Before you have water, after you have water. Just two different forms of the same thing. During a physical change, a substance changes some physical property. But it is still the same material with the same chemical composition. Check this one out. We got water in the gaseous phase, water vapor. Watch this physical change from the vapor to the liquid phase. Yeah. An example of a physical change. You still have water, right? But a different form. What is that? It's a coin. What's it made out of? Well, looks like it's made out of gold. If you look at its physical properties very carefully, very carefully, compare it to what we know is an authentic sample of gold, you see that, they're not quite the same. Real gold's a little more yellow than this gold-looking material here. Well, in fact, this is not made out of gold. This is made out of a mixture of various metals. It's made out of a mixture of copper, zinc, manganese, and nickel, I believe. And the blend of those different metals gives rise to this particular color, which is pretty darn close. But it's not the same thing. We know, if you've had one of these for a while, that it tarnishes after a couple months. Gold doesn't tarnish. We're talking now about what's called a chemical property. And a chemical property is the tendency of a material to change into something else. And as the copper tarnishes, what's happening is there are chemical changes on the surface, whereas the metals are transforming into new materials that have a darkened color. Same thing happens when you have silver tarnishing. There's sulfur compounds in the atmosphere, and the sulfur lands onto the silver, and it reacts with the silver and forms this black material. That's not silver, it's a compound of silver. And that's an example of a chemical property of the silver to transform into the tarnish. We can describe materials by their physical properties. There's another type of property we can use. It's called the chemical property. Let's look at this. Chemical property is the tendency of a substance to change into another substance. We can look, for example, at the coin. And this is a dollar coin, a golden dollar coin, but we know it's not really made out of gold because it has a chemical property of changing. What happens is atoms combine with atoms from the atmosphere to form a material called tarnish. That tarnish is a new material that is formed. And it is a chemical property of the materials of this coin to do that. That's not a chemical property of gold to do that. So although their physical properties might look alike, their chemical properties are markedly different. So a chemical property is the tendency of a substance to change to another substance. When that change occurs, what happens is the following. The atoms rearrange. The atoms will change partners. They'll be in a new orientation. For example, if you had oxygen molecule and a carbon atom, the two might get together to form this material known as carbon dioxide. Carbon dioxide is a new material. It's not oxygen and it is not carbon. It is uniquely carbon dioxide. And carbon dioxide is a gas. And this is what happens when you have a change go on, forming a new material by way of a rearrangement of the atoms. Let's look at this example. Here's some baking soda I put in this test tube, and it is a chemical property of the baking soda to react with vinegar. The baking soda is a solid, and the vinegar is a liquid, and I combine the two to form a gas. I didn't have the gas before. The gas is the new material that was formed. So it is a chemical property of the baking soda to change into a new material. This is carbon dioxide gas, in fact, that is forming from this reaction. I can show you this chemical reaction, this type of chemical reaction in an animation. Here you have your oxygen molecule and your carbon atom. They get together to form a new material, which is carbon dioxide. Similar, but not the same as the baking soda reaction. Here we have carbon atom, oxygen molecule, and when they get together to form a new orientation, you call that a chemical change. A new material has formed by virtue of a change in the way the atoms are arranged. A chemical change is any change involving a rearrangement of the atoms. Got that? If you got that, you'll understand what we mean by a chemical reaction. You've just seen some with the baking soda. That was an example of a chemical reaction. Chemical reaction is the process of a chemical change. During a chemical reaction, new materials are formed by a change in the way the atoms are put together. Here's an example, another example of a chemical change, hence chemical reaction. I've got some water, and I've got a battery. The battery has some platinum electrodes attached to it, and I put the platinum electrodes into the water, and I see the formation of a new material. We have gases that are being formed there, and you see they're bubbling up. On one electrode, sure enough, there's hydrogen being generated. On the other electrode, there's oxygen being generated. We're transforming the water into hydrogen and oxygen. We can say it's a chemical property of the water to transform into hydrogen and oxygen when an electric current passes through it. We see chemical reactions going on here by virtue of the formation of new material. And those are the gases that are being formed. How about this one? This box has some circles in it, and each circle represents an atom. And we see that these atoms are paired off. That means we have molecules. We have the gold molecules and the black molecules. And we're trying to represent a transformation here as we move from left to right. And now we have the gold molecules still up floating around, but down at the bottom now, you have the black molecules all together. The question for you is this representative of a physical or chemical change? During a physical change, you still have what you had. If you start out with a certain type of molecule, you'll end up with the same type of molecule. Remember, like going from water to ice, you still have water molecules. You haven't changed what you have down at the level of atoms and molecules. And so we look at this and we go, looks to me like this is a gaseous phase with two types of materials. And looks like over here we have a liquid phase. Going from a gaseous phase to a liquid phase, an example of a physical change. Do you suppose these are at the same temperature? Do you suppose those two materials have the same boiling points? Which do you suppose has the higher boiling point? How about this question? Take this same box and have a different kind of transformation over to here. Is this an example of a physical or chemical change? Look carefully. During a chemical change, atoms rearrange to form new orientations, new partners. Before, we've got the gold with the gold. Afterwards, we have the gold with the black. The atoms have changed partners. Looks like perhaps we have a new material that was formed. And that's the ticket. If you can identify that a new material has been formed, that's the mark of a chemical change. Got it. And that's it. You got physical properties and physical changes, chemical properties and chemical changes. Good chemistry tip.